If you're trying to solve an exponential equation that only has a single exponential term, for any type of equation, I would recommend simply changing it from exponential form to logarithmic form. Take, for example, if we have an equation like this, 4 to the x power equals 17. Well, there's only one exponential term because there's only one side that has the exponent, right? That 4 to the x is the exponential term. So what I would do is simply change this to logarithmic form. In this equation, the base is 4, so it would be log base 4 of 17, because remember, like we talked in our initial logarithm lesson, whatever is by itself in one form should get to be with the base in the other form. So since 17 was by itself originally, we would put 17 with the base with the log in the other form, meaning that is simply equal to x. Using the change of base formula, you can find log base 4 of 17 no matter what calculator you have. Because remember, the log base 4 of 17 is the same thing as taking simply the log of 17 divided by the log of 4. And so whether you can plug it into your calculator as just the log base 4 of 17 or whether you have to use the change of base, either way, you should be able to go to your calculator and figure out that the log base 4 of 17 comes out to roughly 2.0437. We'll round it off at the 10,000ths. And so that would be your answer for this problem. Even if you have a bunch of extra junk to start off with your problem, you can still use this strategy as long as you have a single exponential term. Take, for example, this problem. We have 4 plus 5 to the 6 minus x power equals 15. There's only one exponential term there, namely the 5 to the 6 minus x power. So since there's only one exponential term, there must be a way that I can get this equation able to be switched or changed into logarithmic form and solve out. Well, in this case, to do that, I would need to start by subtracting 4 to the other side of the equation, giving us 5 to the 6 minus x power equals 11. Because otherwise, if I left the 4 there, there's too many terms for me to be able to shift this into log form, because I'm only supposed to have a base and then two other parts, right? Now we have something that can work for that. We need to treat 6 minus x, that exponent, as one quantity. But now I can say, okay, we have a base of 5, so log base 5 of 11 would be equal to 6 minus x. And so again then, we can go to our calculator and do log base 5 of 11, whether you're typing it in that way, or whether you're using change of base to type it in as log of 11 divided by log of 5. Either way, any of your calculator, a pretty basic calculator should still be able to do this, and you would get around 1.4899. And so that's equal to 6 minus x right now. And then you can just simply solve this out the way you would any other type of algebraic equation. So in this case, you could either add x over or subtract 6 over. We'll say subtract 6. So if you subtract 6 over, then that means you would end up with a negative 4.5101, and that's equal to negative x. Which means whether you look at it as dividing by negative 1 or multiplying by negative 1, since both sides are positive, or both sides are negative, we can also just make both sides positive, which would give us a final answer of x equals 4.5101. The only thing you have to remember is that this strategy only is guaranteed to work if you have a single exponential term. If you have more than one exponential term, there may be better options out there.